Yes. Okay. Yeah. Okay. Total is 50. Okay. With questions. Okay. Yeah, yeah. Yeah, that's not working. Hello? Hello? It's not working. Hello? Hello? Oh, okay. Oh, sorry. Okay. Then this, okay, I have to raise my voice and this pointer is there. Yeah, pointer. Pointer. Like, it's not there. It is not work. This is recording. Pointer is there, or otherwise pointer is there. Yeah, is there? Ah, it is not working. Hello. Hello. Yes, pointer is there. To move this side. Pointer. It's okay. Okay. For connection then. Okay. For this. Hello. Hello. Clear? Okay. Good evening, everyone. Today, now I am speaking on a topic: recent advances in the origin of life. So, origin of life, you all know, like how some important questions are there in biology which are not answered. That Science magazine kept forward 125 questions. Among them, the important ones are: what is life and how did it origin? So, for that many theories were proposed: theory of special creation, abiogenesis theory, and chemical evolution theory, or the famous RNA world theory, and other theories. So, among them, the RNA world theory is the most fascinating subject to know that does life originated from chemicals. So, what is RNA world theory? Before that, going to the RNA world theory, we have to know what RNA actually is. So, as you basically all knows that RNA is a ribonucleic acid. It stores genetic information like DNA, particularly in the viruses, and it acts as like a catalytic. It shows catalytic activity, so that it acts as like a protein molecules. So, it performs both DNA, act like DNA for storing information and act like protein with catalytic activity. This is the importance of this molecule, one molecule performing both the functions, and it acts as a template for the synthesis of the protein. Proteins are very essential for many of the cellular processes. So, this is a central dogma of life, like how like DNA, then from DNA by RNA polymerase, RNA was formed, and then it after translation give protein. So RNA lies very important molecule here, and by reverse transcriptive action, RNA, which is very unstable, can form double helical DNA structure. So what researchers having these properties of DNA like genetic information storing, protein like catalysis. So then, and this RNA acting as an enzyme, particularly in the ribosomes, this RNA acts as autocatalysis for the responsible for protein synthesis. So how this act? You can see here, this is one RNA molecule called R18 polymerase. So this molecule can help in the autocatalysis. It synthesizes a molecule here, which you can see by autocatalysis activity. So this autocatalysis activity can't be performed by either DNA or protein. So this molecule was gained importance, and this is one of the reason why, like, scientists thought that RNA as an important molecule, from there life can start. So, and there are many RNA polymerases, but how this RNA is gained importance, because they act as replicases. That means like RNA polymerases. See, there are different kinds of RNA. These are RNA represented as different strands. This is one strand, this is one strand, this is one strand. So there will be cooperation between them to evolve themselves. That means one molecule in a network help other molecule to evolve. So that is depicted here, like see, this is one RNA A, this is RNA B. So with the help of E, this is an ribosome, which is RNA acting like enzyme. It will help in the synthesis of this molecule A plus B, here form an E, new molecule, with the help of this ribosome enzyme. So scientists then told that this RNA molecules with cooperation, they are evolving and forming new molecules with their catalysis activity. Not only that, different RNA, you can see, like this is one different RNA strand different. So they all together in cooperation, they are forming an internal guiding sequence. So with this they form their catalysis activity. This is from the recombinase having different strands of RNA to function with cooperation. So another, not only this, like previously, as all of you know, like Stanley Miller experiment, where some basic units like ammonium, carbon dioxide, nitrogen and water vapor, with this they synthesize amino acids, which are basic requirement for the cell to synthesize protein and later. So this is another, like they never showed that the nucleic acids are also prepared by this process. This paper in Nature Chemistry, this what the scientists done is they used hydrogen sulfide with copper as a catalyst, and they found all the three molecules, important molecules for the synthesis of life, they were produced, like RNA, protein and lipid. In this pathway you can see the nucleic acids were produced. Here glycerol, which is a lipid, like it precursor for lipids, and here amino acids like arginine. And so this is similar as a Stanley Miller experiment, which we are providing the basic things and we are getting the precursors, but this is not, this can't give life itself. They have to form polymers, then only their life can exist. That means then life can chance of forming, but with the precursors this is one success. But there are many limitations are there. What are the limitations means? Like for a molecule to form, like RNA precursors were formed here, like nucleic acids, but it should form a chain, a polymer which is functional. So for it to form a chain, it requires a template for copying. If DNA was copied, then RNA forms. Otherwise RNA form copied then. But how the precursor polynucleotide polymer came, that was not answered. And other limitation, it can't be a polymerase, that means an enzyme and a template. It can't act. Single molecule is there. It can either catalysis or it can perform as a template for other molecule to copy, get copied, or performing its enzyme activity. But one molecule first, during origin, one molecule can't do it. That is one limitation. So it needs other molecule, two molecules, one has template, one has replicase. So copies were produced. And how was the first was error? Like I said, like precursors, they found by this experiment, recent experiment. But how the first is RNA, this polymer form was not known. Other thing, stability of RNA. DNA has a double helical, it forms stable, but RNA is not stable. That too in that those environments where lightning is there and very high temperature is there. RNA can withstand temperature, but it's susceptible to other exonuclease and other not much stable because of this ribose sugar and substrate availability. Okay, this can act as an enzyme, but there should be large amount of substrate should be there for it to function. Suppose substrate is here and enzyme is there, then it can't polymerase, it can't form polymers, because during earlier times what the researchers, even though the Stanley Miller experiment or the recent Nature Chemistry that experiment, they said they used chemicals, precursors chemicals, they got the end product, but the end products are very less, particularly amino acids. Not only amino acids, there are different products are there, but amino acids were very less. So the substrate availability is also one limitation. And environmental factors. Scientists are trying by different changing conditions like pressure, temperature, and other conditions. So on which condition does this RNA can form as a polymer, or RNA can form as a like even the nucleotide forms. So but they are not found anything, and they don't know what is the earlier temperature, pressure at that time. So they are doing research on that also. And strand separation, okay, this some polymer is there, now RNA with this replicase activity form a double stranded, but for DNA helicase is there to separate, but RNA there is no molecule like two helical is there, then which molecule to separate? So it can become separate two strands, one will be synthesized this side and other will be this synthesized. So that way the population can increase. But though that means a good amount of research suggests that this may be the molecule, but these are the questions that are there to be answered, so that we can think that okay, this is the one molecule which is chemically evolved to give life. But not about the molecule itself, it needs other. Cell is not made up of one molecule or two, it needs many thousands of molecules. At least in proteins of 20,000 or minimum is required, something like that. So is it possible to synthesize life from the chemical? We are talking about, this is the RNA which act as a replicases with enzyme activity, and so and these are the vesicles, these are the lipid bilayer, which generally cells are covered by this bilayers. And when this when these replicases entered into this vesicles due to the penetration, so they form this RNA encapsulated vesicles. So is this life? No. Although it's having this replicase activity, it should have the substrates, and these vesicles are both can be. You need many of the factors to form a life, functional cell. So the conclusion, like many theories of origin of life was proposed, but some are acceptable, like, but not completely, and still more to be proven, so that to accept any theory as fully correct. So this shows that like RNA was not the life molecule. From there we can blindly say, like, up to, we know that's not blindly, like scientists have done a considerable amount, but to know more, like they are like child about knowing about the big thing. So further experiments should be proven to accept this theory as the complete theory, so that we can say that life originated from chemical, that to RNA. So this is the complexity of the cell, which you can see, and RNA will be small molecules in that everywhere, and having the bilayer. So this much complexity coming from a simple molecule is a fascinating subject. So any questions? Yeah.
No, then
Yeah, he's there.
Anyone?
Yeah.
Do you think that virus is life?
No. Virus is not alive. It gain, that means it it's like parasite, you can say, like go into other one, then only it can gain its function. Otherwise it's not having any. Yeah, it can bring life. How? The virus enter a some other, like suppose a rudimentary cell, then it can form. But this is not proven. If you see that Vikram Singh was, we are not like, there is also one concept, that panspermic theory, that one, that is also not fully proven. So they hypothesis. Yeah, hypothesis. All this is hypothesis, but much is achieved by this RNA world theory compared to other theories, because that much proof is there. But then also it is far away. This many questions, limitations are there for RNA world itself. Much to be done to say this. So those also hypotheses, but there are evidences out there, like with meteors, comets. Further experiments should be done. Even that, okay, it can start a basic level, but forming a complex cell from a virus is. Repeat the question. Yeah. Like bacteria? Who? Okay. Yeah. 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 What is life means, like till now that is the question. Like science published 125 questions, general science. So that means we are advanced scientifically, more advanced we can solve problems, we can cure diseases, but there are still more questions are there. The important one is the scientists can't define what life is, but there are symptoms. Life means growth will be there, replication will be there, that it can produce its progeny, it can feel, it have consciousness, all these things are there. That's why we are selling life, but actual definition they can't define. And how life begin is another big question. Yeah.
Anyone else? No? Then let me thank Shashi. Thank you very much.
Okay, welcome you all. I hope your quest on the way to find life, maybe at the end of session you may find it. Okay, thank you. So this is abortion is it became a very nowadays last 50 years it became a household term. Like everybody, is very well known term. Is everybody knows it. This is just like a termination of pregnancy or a fetus development before it takes a birth. So the question is like actually this why this abortion is very important is there are actually in every 2 seconds we are in the world, actually especially in the USA, 2 babies were killed like in the abortion. Okay, and in USA from 1973 there are 57 million fetus are terminated, which is almost more or less equal to or more than that population of Switzerland, Austria, Sweden, Finland, Denmark. So it's like we have to create another continent to accommodate these people. Then this act asks us whether this act is moral, is to terminate these fetus or infant babies. So the question is like after terminating the pregnancy, like fetus development, many women they undergone the traumatic and PSTD and grief. Then they ask the question: is terminating pregnancy is equal to an infanticide? So generally we may not think that okay, this is not infanticide. Generally it's very immoral to kill an infant. Okay, but is it the same thing applied to the embryo or a fetus? So this is the same question I am going to ask: is destroying early embryo equal to killing or harming a human person? Generally, when we give the death penalty to a prisoner or a criminal or a terrorist, we say this country is very cruel, this is this country laws and acts are belongs to something to 2 centuries back or something. Then we say very cruel this act is. But is it also same applies to okay? Is it also applies to terminating pregnancy or embryo or fetus? What do you think? Then the question actually, some people may say yes, some people may say okay, it's just a group of cells actually. Yes, it may not be human being. So there are different opinions among the scientists and philosophers and the public. So this was the one of the fundamental question which was one of the fundamental question in reproductive ethics. So some people says this early embryo or zygote is just a group of cells, and some other people says early embryo doesn't have any consciousness or sentience we call in the science, so it cannot have any feelings and terms. Generally in some philosophers they define human beings has some expressions and some feelings. This is considered to be a human being, but this embryo doesn't have any such kind of things. So people say so this may not be human being, and babies are not human till the birth. Some people say they don't resemble like that fetus or embryo, early embryo. It doesn't look like a human being, so it doesn't resemble. So it may not be human. So it is moral to do the such thing. But then the question is like early embryo or zygote is just a group of cells. Then the question asks in that is just okay. Okay, the question is like when does actually life enters in the embryo during the course of development from the single cell just after the conception till the birth of the infant. Actually, when does this human being entering? That is what, when does new human life enters? This is one of the fundamental question in the reproductive abortion ethics. And early embryo doesn't have. So then the question asks, okay, if the embryo doesn't have any expressions and feelings, this is also like when the person in the comatose means vegetative state, he also doesn't have any feelings and expressions. But we cannot actually terminate him, or we cannot give euthanasia to him, or we cannot kill him. It is very immoral, it is against to the moral status of him. So this is also a contradictory to that one. The next question is, babies are not humans until the birth. Then the question comes like, what is the life present before the birth? Are they not humans? Then when actually this human entered in this? The question next. So these are the fundamental questions. Now it's to solve this problem, whether it is a moral or immoral, we have to address all these three questions. So we just have, I want to go to the scientific and Vedantic perspective, just have a look. Next, so generally people say abortion ethics is just values, but always if you don't get facts, you may not get ethics. So ethics must be based on facts rather than values. If you don't get ethics, your facts right, you will not get your values right. Also, you don't get your ethics right. So then the question is, at what time frame does human life commence? In the terms from the single cell, from the just after the fertilization till the course of development, like 24 weeks of the embryo development. At what stage and what time frame actually life enters? We all actually taken birth, but we never thought about it. But recent advancement in the science, in the especially IVF technology or embryonic stem cell research, these are the questions need to be asked and to be solved. Otherwise, so when actually human embryo or a fetus is a human person with a basic human rights, when it will get? So then to address this, actually the question is, when we have to ask, is a zygote a human or a cell? Just after fertilization of the sperm with the oocyte of the mother, it is called fertilization. So this process, then this is called, after this fertilization, it's called a zygote in the scientific term. So the question is zygote is a human cell, or a just cell of the human, or a human organism, or a collection of human cells? So some people may say it's just a human cell, or it's just a collection of human cells, like or some people say it's a human. But which one is true? How you judge it? So to address this problem, to solve this problem, actually to define an organism or define any living organism, in the scientific and National Institute of Health USA, it gives a definition that organism actually has a interdependent and coordination functions, and it preserves the life. Means like even though we have billions of cells, when the life is present, all the cells, they work together, the interdependent and coordinate manner to preserve the life. When life is absent, these cells, they lose the interdependent coordinated function. Like even the dead body, you will find the living cells, but they lose their interdependent coordinated function of working and preserve the life. That is the symptom of living organism. So now we will check actually whether this zygote actually really human or a human cell or a collection of human cells. So this just after the fertilization, just after the sperm enters into the oocyte, immediately within the 30 seconds or 15 seconds, it changes the ionic composition of the calcium ionic composition on the membranes. This is just in 30 seconds or 18 seconds, it completely changes the calcium ion composition. So that this ionic composition actually blocks the further introduction of sperms. So it blocks the polysperm, so that no more sperms will. So it is like this act is this act is directly going to the further blocking of further impediments to the human organism life. So and immediately it activates the tyrosine kinase pathway signaling activity, and its tyrosine kinase localization also changes, and redox state also changes in the zygote. When the reduction changes is even slightly altered, you will see the severe defects in the human development. So this act is like a human, this zygote, even the cell, it acts as a even coordinated manner. It will not allow any further disturbances. It acts as a coordinated unit for the further development of to become a human being. Even any obstacles like a polycerm or anything, it will not entertain. This is the one kind of act, so that it shows that it may be a human organism. Next. So next also, just after even 30 minutes, and it changes the lot of, it undergo extensively epigenetic modifications, like paternally derived nuclei changes the maternally derived nucleus, epigenetical modification like demethylation, acetylation, these things, so that further the activation of gene transcription. And paternally derived factors help the replication. Here is the epigenetic modification cycles, like how it changes how maternally and paternally both DNA coordinates each other. This is like, even though these do different chromosomes present, but they worked in a coordination manner for the further development of the human being. These kind of acts actually shows that this zygote is not a mere cell, but it is actually human. Like it's as a living organism, may not be human, but it's a living organism. So the conclusion of this scientific perspective, so it says zygote does not act like a human gamete. Means just after fertilization, it loses its gamete markers. Means like it cannot act as a sperm, it cannot act as a oocyte. It acts as a zygote for the development of human. So it says that it cannot be a gamete, and even this, it is not a collection of human cells. It acting as a coordinated manner. If you culture the epithelial cells or skin cells or any lung cells, it will not give you this coordination pattern to develop the human being. This is the difference between the human cell and a zygote, human zygote, living organism. So this zygote has this property to give rise a human organism to this thing. And so new human life actually commences at the moment of fertilization. Means the moment of fertilization, it changes this directive the development of the oocyte, and it completely changes towards the development of human being. So it also says that this new human life commences at the moment of fertilization. From that period onwards, new cell come into existence. That cell is zygote, is acting as in coordinator and interdependent manner to preserve the life. This is the hallmark of the organism. It means that this cell zygote is not a just cell, but it is a living organism. So that means the life actually is entering at the moment of conception. Just means just after the fertilization. Just after the fertilization means just. Okay. So but the question remains, how human cells maintain interdependent coordination fashion? What actually makes these cells to work in interdependent and coordinated manner? What we call a human organism, living organism. What actually makes them to work like that? So this question, to address this question, is something which is like actually beyond our empirical knowledge. So we have to look other knowledge, like we need a paradigm shift where we can actually get this kind of answers. So for this answer we need a Vedanta. There are a couple of questions. Even though life is present in the zygote, okay, but what is exactly that life is? Okay, no problem. Thank you. So then if it is some people say life is just mere collection of biomolecules. If it is a collection of biomolecules, DNA, RNA is wasting these biomolecules is not a big deal, but still we worry more. So then what it is? Then Vedanta says, according to Vedanta, living being means the living being has a genome. It's a physical body, what we call genome, and mind, intelligence, false ego, and spiriton. This, if spiriton is not present, this body, the physical body, the genome, it will not give the living symptoms. So this is, even if the dead body, even though it has a living cells, but it cannot act as a coordination fashion. So it loses the living organism symptoms. That is why spiriton is important. So this spiriton, it actually, Vedanta says, life begins at the moment of conception. First this life enters into the sperm and it will be injected to the womb of mother. So this embryo, it says that we have a very detailed description in the Vedantic embryology in the Garbhopanishad and Srimad Bhagavatam. If you have time, you can go through my article, which is there in the proceeding. So Vedanta says actually why it is so important. Actually, according to Vedanta, the spirit has a according to life is very sacred. It has a purpose and meaning. When you actually terminate the life, it nullifies the achieving highest perfection of life to realizing the self and supreme self. So he may lose his purpose of life. It may not be good. It is very immoral and unacceptable. So the conclusion of my talk is, life enters at the moment of conception, and same human exists from the single cell zygote to mature individual. Disturbing life at any moment after conception strictly prohibited. It is immoral. It is like more or less equal to the killing or harming the human individual. So abortion nullifies chance of achieving highest perfection of life, realizing self and supreme self. Thank you very much. If you have any questions, please ask. Yes, please.
But somehow single body but double head, which is single body. Is it a single life or is
See, that's what I told. Genome, the living organism means genome plus spiriton and living body. You may have genome like lot of, you may have extra hands and everything. That is a physical matter. Okay, but the living entity is like the spiriton is only one present in that person. Yes, please.
Just continue this question.
Okay.
If there are two heads, is it there possible they'll think differently?
No, actually, even though they possess two heads also, they think the same. The only it differs when the persons in the monogenetic twins means they possess the same genetic constitution, but they think differently.
They will have, they may have two minds, two brains, but they will have only a single soul.
Yeah. Yes.
So the thinking is a property of
Soul.
right?
Yes. Sorry? Yeah, actually in the family screening, actually we terminate the feet. Okay, actually that is different. That is two different questions. Okay, when no, if person having two heads and with a single body is having one soul, but the person, two persons is actually having the connection, that is two different individual beings. That is the two hearts. Yeah, but even if it appears like it's a breaking of zygote, but actually two zygotes actually they work as a organism, like a organism living symptoms. Yeah, actually after, it's not after 9th day, after disease happens after 24 hours, after the first cell division happens, it takes place. So these two cells of the zygotes grow as a independent. Like if it is two cells divided from the single zygote, it gives you monozygotic twins. If the two oocytes is actually fertilized by two different cells, it gives the zygotic living cells. So these two things actually two different. So this what I told. The spirit, the life actually enters under this direction of the Supreme Lord. So this is actually two different events. Yeah, even monozygotes also. Huh? Because after cleavage of first cell division, these two cells can have two different. Actually in Vedanta says wherever the movement of the to get the living body, their cell can enter, soul can enter actually. So just after cell division, the soul can enter into that zygote, that cell, particular cell. So it gives two different individuals. Huh? After 9 days. Actually pluripotent stem cells, actually it has the ability to give the complete human organism, but actually this experiments is not yet reached the stage where you can actually take all the cells, take the culture individual cells and give rise the human being. So that can be possible.
No, I think ma'am is asking about when they are splitting into two, what is it? So it's like DCDA, dicarbonyl diamine.
That's what I told, madam. Like when the two cells, there is an opportunity, the spiriton enters.
They say that we are different beings, but attached to each other, like that we are having problems.
Yeah, two different beings. Maybe that's what the two. No problem. No problem. Even the two bodies are attached. It's because the thinking and willing power is something. It's not belongs to the genome. It's not belongs to the matter. Yeah, it belongs to spiriton. Thank you.
Now I invite third speaker, Kali Charan. This topic is Jet Engine, Perspective on Intelligent Design and Fine Tuning. Dr. Kali Charan is Engineering Manager at GE India Technologies.
Yes, true.
ये चाहिए क्या? ये चाहिए?
कौन सा?
इसमें?
अब बोलेंगे ना
हाँ,
तो फिर रिकॉर्डिंग होगा।
और रिकॉर्डिंग चाहिए।
पॉइंटर नहीं आ
पॉइंटर देखा। लेजर है ना, ओके। इसको भी चाहिए। सब लोग तो चला गया। The live gaze of God. Okay. Hope you will be interested in jet engines. Everybody is. So what we are going to talk is what is the intelligence behind the jet engines, and if there is a need of intelligence behind the jet engines, then we will discuss. So what we are going to discuss is 2 points here. One is intelligent design and fine tuning. So what is meant by an intelligent design? Can we call any design as an intelligent design? So here is a typical our old Indian ambassador car. So an intelligent design, there is a word called irreducible complexity. Irreducible complexity means, you see this car is made up of so many components. Apparently it looks to be very complex. But if I take out this or one wheel, do you think it will really work as a car? Not really, right? So if you can think of a design, that means you cannot reduce the complexity of the design. So that design is called an intelligent design, and it will point to a purpose. As soon as you see this design, you think it is meant for traveling, right? Definitely not for something else. So what do you mean by fine tuning? So every design may not be fine tuned, at least when we are designing by human beings. But you will see in nature every design is fine tuned. But here you see 2 designs, right? One is an ambassador car and another recently launched by Maruti, CS, right? So what Maruti is claiming, or the mileage of this CS, they are claiming that for every kilometer they can run 28 kilometers per liter. But what is the mileage of Maruti, right? So far as the design is concerned, it has a diesel engine, right? It has all the essential components for the design to work, essentially to travel. But one will give a mileage of maybe 15, 12, okay. But here is the design, it says it will go for 28 miles, right, 28 kilometers. So this is, what does it mean? It means that they have refined essentially the diesel engine. Probably the compressor ratio of these 2 engines will be different. The heat loss during the combustion process is better here, right? It is not as so much. So that's why you see it is able to give 28 miles. So what one can say is it is a finer tuned. I will say it is a finer tuned because somebody can else, because it is a human design, right? It is not, it is the finest. So it's but it gives you an understanding. What do you mean by a fine tune? But in nature, if you see any design, you will see it is fine tuned, because it's a kind of a stage it is reached to its refined and most optimal stage. So I hope you understood the difference between the intelligent design and fine tuning. So we didn't want to discuss more about automobiles. We'll get into jet engines. Okay. So always, as human beings, right, we wanted to want to fly like birds, right? Somebody, Wright brothers, in 1904 or 5, they thought of flying. So if you have to fly, what are the basic things are required, right? You want to fly. If you want to fly, there has to be a continuous thrust, isn't it? But if you want to move, nature is there is air, so there will be drag, right, because of friction. So but automatically you have to have so much of thrust beyond the drag. That means you have to have a prime mover like an engine, and apart from that you don't want to fly on the ground, right? You want to fly in the sky, so you have to lift. So there has to be a lift. So we have our natural weight and there has to be a lift force. So something you need to design that which can propel, will give you continuous thrust, and another one is in the design you need something to lift. So those are the very basic things. Apart from that you have some control of maneuver loads and other things. So how does, to get a continuous thrust you need an engine, a jet engine, and where from we get lift? We get from the wings. So those are the two things we are going to discuss. So if you look at a jet engine, right, it appears very, very complex, the most complex you can see, even like a human body, right? So is it any of these components are not required? Definitely they will not be designed like that. So this is a very simplified view of a gas turbine engine, but the fundamental principle is based on the Brayton cycle. You may not be not knowing. Okay, so I'll try to explain it in a very layman language. So what a gas turbine engine has is essentially at the inlet we get the fan. You might have at least seen in the aircraft there is a rotor rotating and then much thousands of speed RPM, and with that the air is sucked, and the first component it is a compressor, right? Why does we need a compressor? Because unless we compress it, so there has to be a fuel injection, so the temperature has to be higher. If you want to burn a fuel, then the temperature has to be higher, and also for a certain combustion efficiency you need the temperature to be higher and the pressure also need to be higher. So that's why you need a compressor. But to drive a compressor, right, there has to be something to drive. So that's what you need a turbine, right? So the turbine and compressor are the same shaft. So this turbine is trying to drive the compressor. But before that we inject fuel, right? So how the turbine will again rotate is, turbine is basically, it is a conversion of this fuel energy which is getting into the combustor, right? So that energy, when you put the combustion process, the enthalpy or the temperature or the energy level, you can think in a layman term, and this energy level from when it enters from the inlet of the turbine to the exit of the turbine, the energy level reduces, and that energy level, that enthalpy is essentially trying to rotate the turbine, and when the turbine is rotating the compressor will also rotate, it will also continuously suck the air. So that will go like a continuous process. So after that, so this is, we have a high pressure turbine or a low pressure turbine, essentially it does the same thing. After that it will pass through a nozzle. So what is the function of a nozzle? It will generate high velocity at the exit of the turbine. So when this this air stream goes with a high velocity, then you think what will happen? It will try to create a equal and opposite reaction. As for Newton's third law, the aircraft will move. So what I am trying to say is, each and every component in this design has a particular purpose. I can't think I can get rid of this low pressure compressor or high pressure compressor. I can't think of getting rid of this combustor. I can't think of getting rid of a turbine. I can't think getting rid of a nozzle. Apart from that, several other complexity are there we don't have to discuss in this session. So what I am trying to say is each and every component of this jet engine, although apparently it looks to be very complex, right, but it has a specific purpose. And now we are going to discuss some of the intelligent design of maybe some of each of the sub components, right. So do you know why India so far for last 50 years it could not develop a jet engine, right? Because particularly we are not able to design the hot section, the turbine section, right. The turbine, which is essentially after the combustor, right, we are not able to design the turbine blade section, or we do not have materials. So these turbines are essentially operating at the exit of the combustor. The temperature levels is about more than 3500 Fahrenheit. Okay. So to operate at that temperature, we do not have materials. We do not have any material in the creation, at least at this point, right, which can sustain 3500 degree Fahrenheit. But the efficiency of a jet engine will be as good as this temperature is highest. So everybody in the jet engine designers are trying to push this temperature up. So the guy who is designing a highest temperature, he will be the smartest guy. The fuel efficiency will be much better. So then how do we do, right? So what essentially we do in that case is we take the compressor, which is where we do not have the combustion fuel. So we take some cold air, right? So that's what you see from the compressor. We take some cold air and through this cold air, so what you see, this blade, right, some hot airs will be going on the flow path. The 3000 degree 500 air will be going through this, but maybe about 1000 degree Fahrenheit cold air is coming here. You see there will be lot of holes from here. They are basically coming out and forming a film. So what we call that in terms of fluid dynamics and heat transfer is called film cooling. So it will form a film, a cold air film will be formed, and over that cold film we will have a high temperature. So the cold film of 1000 degree Fahrenheit is on the surface of the metal, and over that you have 3500 degree hot air. Can you think of? And the thin film, it is just like a film which is protecting, and if that will act like a film as long as I maintain certain pressure ratio. If the velocity is very high, you think of some air is coming with a high velocity, it will not act as a film, it will just come out. And if it is not having sufficient velocity, it will also not act as a film. What I am trying to say is, you think how intelligently the turbine blades are designed. So there are certain reasons why we were not able to design, maybe, right, in India. So another component is, so you see in our engines, right, you see on the front of the gas turbine, it is rotating at maybe around 2000 RPM, and it is covered by a stator, right. So there has to be a gap, is it not, between a stator and rotor. You cannot just combine, there has to be a gap. So in all these designs, so you have a stator and rotor, so there is a gap at the top. And do you know what is the gap? The thickness or the gap is just as thick as our hair. So if the thickness is very high, what will happen? Instead of the air is getting compressed, all the air will go out through the gap. So you will not get any compression. So think that the rotor is rotating at maybe 20,000 RPM and also operating maybe thousands of Fahrenheit, and you think the jet engine is going from its ground idle speed to take off in within 10 seconds, right? You might have seen when it is taking off, right? And at that time the temperature itself is changing much and the speed is changing, so various forces are acting. Then how do you design this small gap? Still it has to maintain a small gap as like a thickness of air. So you can imagine, right, there is a lot of intelligence is going behind this. And another thing we are discussing is how we are, not only we have to generate thrust, it also has to, we have to lift, right. So you are always seeing these wings when you are on the window side of the aircraft. So what is happening, right? So this is the inner structure of the wing, but if you look at closely look at the cross section of the wing, it is it is in this shape. I don't know, we call it airfoil shape, right? So, but why it has to be such curved shape? If it is straight, we will not get lift. So if you see here, right, what happens? The flow is coming through a higher length and this guy is going through a lower length. So generally you will see this velocity will be lower. So the pressure will be higher here, and here the velocity will be higher and pressure will be lower. So there will be a delta difference in pressure. So which generates delta P or lift. Okay. So apart from that, there are so many other things. So what it says is the airfoil shape is also intelligently designed. So we have been having, all aircraft designers, they have been having so many aircrafts are running, but still, this is one of the upcoming narrow body aircraft or engine, LEAP engine, which will be entering into service in 2017. We are doing in GE. In 2017 it will enter, and its fuel efficiency will be 15% better than what we had earlier, and it will be 50% lower in NOx, right? The emission is also coming into play by the government agencies. So the efficiency, the NOx efficiency has to be lower. That means the combustor, what we are operating, the combustion efficiency has to be better. Apart from that, it will be lot quieter. I don't know how many of you have traveled in a Dreamliner 787 recently. It will be as quiet like, you will never know that an aircraft is going on. So what it means is the fundamental design is same, but how you can do it better. So you can see there are so many improvements. So basically refinements are going. I don't think I can discuss within this limited period of time. Okay. So, but even after.
Sorry to interrupt. Apart from the design of the so-called turbines, the main design for the Dreamliner is to have a lightweight of the aircraft.
Yeah.
So they are using this metal components.
Correct. So that is in the yeah. So but what I am trying to say, so even after so many designs, you have to have hundreds of tests. Even you do in your computer simulations, you have to have 100 of tests, and you will see in every test we see that there were such failure, this and that failure, right? In each of these tests you will see so many failures, and again we redesign. But even after you do designs, what happens? You see there is flume coming. Everybody in danger, right? So even though you do so much of intelligent design, so many of refinements, so many of certification tests, but still you meet in this. But you see this. So this is just, so we have discussed so much how so much intelligence gets into the design of an aircraft. So you just think of this bird, right? How it is taking a maneuver. Can you imagine an aircraft is taking such maneuvers? Can you think of these flock of birds, how they are flying, right? If you think of how much of intelligence design is required to do this maneuver. So where is the engine? So this design is not only an intelligent design, there is also an intelligent being itself, which is intelligent itself. The design itself is intelligent. Do you understand what I mean? So apart from that, within the creation, so not only these birds, so there is a gigantic creation, right, which is also how nicely he is operating. So that's what Professor Newton, what he is saying. This must be, so there must have been a intelligent, it must be coming from the counsel and dominion of an intelligent being. Right, in GE we are designing 10,000 engineers are there to design an aircraft, and that takes 7 to 10 years. Then how does these designs are coming without somebody doing it? And not only that, these designs are also fine tuned, not finer tuned as I discussed. These designs are fine tuned. Then who is the designer? There must be a designer, right? So who is the designer? That definition we will not get in jet engines. So here in Bhagavad Gita or in Vedanta Sutra, it is defined. Who is the intelligent designer? That intelligent designer is one who makes this creation, and apart from that, Krishna directly says, I am the designer. So with this, not only I am convinced, so here is Einstein. What he is saying, that everyone who is seriously, right, not to make a job, one who is seriously involved in the pursuit of science becomes convinced that there is a spirit, there is a designer manifest in the laws of the universe and in the creation. But here Einstein says, I want to know how the creator God created this world. But what I would say, it's not only how, we should also ask the question why. Why he has created this creation, this intelligent design. Not only intelligence design, the design which said is intelligent, like the human beings, that themselves are intelligent. The design is intelligent design, and apart from that, the design itself is intelligent. What do you think? Okay, so then there must be a purpose. So what is the purpose? That is also given in the scripture in our Ved Upanishads. So this is what it says. So if the intelligent design as a human beings, what we should be doing? So what it says is, you know this, I think you can ponder over it. So with this I will stop here.
So how much jet engine is intelligent?
It is not intelligent, it is intelligently designed.
Yeah, so again that is again a good question. So how intelligent is jet engine, right? So we try to design the jet engine to some extent to be intelligent by an intelligent designer like us. So for example, if there is something fire is coming, right? So we put some probes, right? If somewhere the probe is there, if the temperature has exceeded, right, it will give an alarm to the pilot, isn't it? So we try to bring some intelligence into the jet engine. So for example, if the temperature, suppose the temperature or the pressure level somewhere inside the sump or something, right, oil is coming out, so there can be fire, right? So we try to design the gas turbine or the jet engines by putting probes or whatever, by the intelligent design or the intelligent people designed by the Lord, right? So
if everything is intelligently designed in this nature,
yeah.
why there will be some defects in the design? For instance, as she was discussing co-joined twins. So when the two embryos develop into two different entities, there will be some defect, some metabolic or something. So there will be co-joined. So those two twins join together for their life. Why is what's the problem? What is the, how can you explain the effects of it?
Yeah, so maybe not from jet engine's experience. Yeah, so I'll give you the answer.
Actually, you showed in your jet
Yeah.
at the end you saw some defect in that. Some
Right.
gas is coming out.
Yeah. So why do you think that is not intelligently designed? No, you just try to listen, right? So why do you think so apparently it appears that the two living entities are joined with a single body. Why do we think it is not intelligently designed? Actually, no, listen, and if you have read, I will not make my statement, what Krishna is telling in Bhagavad Gita 13.22. He says, Karana Guna Sangasha, right? There is a cause why a living entity is taking a particular species, right, or a particular type of body is governed by the law of karma. So we do not know, so we don't have the intelligence to see what is happening and why this is there. We think that it is because of the defect, but there is an intelligent reason behind that. We will definitely, we are not.
Like Watson also that have been developed recently that have capacities which go beyond human capacities. Would you at some point be willing to say that the system could be named intelligent itself?
So probably I didn't.
Okay.
So you can come.
So my question was, you had this very nice comment at the beginning, where you said it's not intelligent, it's intelligent design, and I want to go in this direction. So the intelligence design, we have today very complex systems out there in the area of artificial intelligence, and I mean the app is a very intelligent part. Let's be careful. It's a very complex system in the first place, and then in the area of AI, we see more and more systems which now, like Google cars, will drive autonomously. They get more and more capabilities built in. We have seen Watson system and so on. And in more and more areas, these systems which have a huge complexity, which probably follow according to your talk, intelligent design, will probably come up with capabilities which, at least in certain areas, are superior to our capabilities, to human capabilities. I mean, we have seen Watson system that beat the human players in the Jeopardy puzzle and on television. So the best human players, or in chess playing the game slots. So we will never ever have a human chess world champion. So how much? Therefore, I want to come back. I mean, can intelligent design then lead at some point to systems which are intelligence in the sense of human intelligence, or what's the difference?
Yeah, so I'll just try to summarize your question. So, can at any point of time we can design an intelligent design can be as good as intelligent like we, right? Are more intelligent. So, so at least in the principle, what we understand is it cannot be, because the intelligence we get is at least from our understanding, or from our principle, that the intelligence what we get is from a conscious higher source, right? And how much we utilize that to design an intelligent system. So so when we design an intelligent system, that is limited to the intelligence we had during that time, right? So maybe I have designed so for example, if I give you an example, right? So GE designed an aircraft, right, which was maybe 15% lower efficiency 30 years back. Then how they could design another design which is 15% more efficient and 50% more lower in NOx and even quieter. And I am sure, we have again a plan to design another design in 2025, which will be further and more efficient probably than this. So it clearly says that any creation, anything we design is evolving, right? So we don't have clues, but we think we can design after 20 years or a better design. Hopefully we do. I hope you got the point.
So basically we are honing our own skills to make more intelligent systems which are less intelligent.
Yeah.
So that means if anything intelligent design, any nature is created, so the evolution is also taking place.
No.
My point is, there is a design, and there is an evolution as well. think evolution is first. Evolution is complementary.
Evolution of intelligence.
Because they are connecting your thought from the morning, the viral integration and results into the molecular evolution, what the what is somebody told. So I'm just connecting both of them. Because there also here we are telling intelligently life is created. And the viral particle came and causes evolution of selection of something. So, but again you are telling that this design after some time they are evolving.
Correct.
Better design. So in this particular life, so many living organisms, some will die. Again coming to the evolutionary principle. So some will be survived. So
No, but you cannot do an analogy like that. So just put your right question accordingly. I will give the answer. You put your question in short.
I'm putting only one question that the evolution is also going on, intelligent design is also going on. Both are complementary in each other. That's my question.
Evolution of what?
Evolution of,
This is a evolution of a jet engine.
I'm telling you evolution of living organisms.
He's saying evolution of life, I guess.
Evolution of species, right? You are talking about Darwin's theory, right?
Not only Darwin's theory, so many theories, evolution.
Not what? Evolution means we have species. That may be a theory, but we have different species.
We don't see evolution, macroevolution. Like one species very next to the other, but there is evolution in micro scale. So you are getting antibody resistance.
That's what my point.
There is evolution going on always.
So that means
so we are
it's
changing our shapes. The shapes we had before all the hominid species. We are having different shapes now. The skull, the body, the fingers. We are getting there. And the spiders, since they are building evolution, they are taking some part of that.
That's what my point is. Both are
It's going on. Both are going on.
That's
Intelligence, evolution of the body and the mind, both are going on.
I'm getting the signals that time is up and we have, some still. So really, I feel that everybody in the audience, they felt very greatly involved on the ground. And the topic itself was very intelligent. And you started with jet engines and came to intelligent design, fine tuning. So the discussion was and the presentation was so nice and encouraging that everybody got involved, and even the evolution of intelligence came in the discussion. So thank you very much. So before concluding this session, I request Professor P.K. Singh to hand over memento in respect of his token of this session. I request Mr. Sasikumar to come on to dais and then accept this token of appreciation from Professor P.K. Singh. Thank you very much. So now I call upon Mr. Srikanth to the dais and then accept this token of appreciation from Professor P.K. Singh. Brought very nice topical perspective. Now I request Dr. Kalchar Naik to accept that. So now I request Mr. Prabhakar from Bangalore to hand over a token of appreciation to the session chair, Professor P.K. Singh. It's very. So finally, thank you, Professor P.K. Singh, for nicely organizing the session as well as giving wonderful lectures by all these three speakers. Thank you very much.